Audio Jungle. Audio Jungle.
First example is the Pyrol and another nitrogen have positive charge. So Pyrol have cyclic compound. Okay, here you can see. You should solve the examples, many examples, so you can understand how many pi electrons should I count and how the pi electrons are counts here. Okay, you should simply solve the examples. Okay, I will make the video about it, okay, in the next video. So simply here you can see that it is cyclic. It have delocalized conjugated pi system. Why? Because all the three valency are satisfied. Okay, all the three valency are satisfied. But if here you can see that remaining p orbital will be parallel to the another p orbital. Remember one thing, that if three bonds, okay, here three valency are satisfied and remaining p orbital or lone pair will be parallel to the another p orbital like this. Okay, you can see. And if you cannot draw the structure in your exam, so remember one thing, if two pi bonds are separated by one sigma bond, so there will be conjugation. If one pi bond and lone pair, one pi bond and negative charge, one pi bond and positive charge separated by one sigma bond, there will be always in conjugation. Okay, simply remember this trick. Okay, you can simply calculate it. Okay, so here you can see that this cyclic molecule, pi bonds are separated by one sigma bond. Here also lone pair pi bond separated by one sigma bond. So it is conjugated system. It have how many pi electrons? 1, 2, 2 and 2. This lone pair also take part in conjugation, 6 pi electrons, and 6 pi electrons. It is aromatic system. Okay, you can see here for n plus 2 is equal to 6. Okay, and n is equal to 1 integer value. Another is the flat. Okay, it is flat molecule. All the carbon have sp2 hybridization. Okay, so it is aromatic compound. But what about this n plus? Okay, it is cyclic, conjugated. Why? Positive and pi bonds and another pi bonds are separated by one sigma bonds. Okay, and positive and pi bonds are also separated by one sigma bond. So it is conjugated pi system. Third rule is 4n plus 2 pi rule. But how many pi electrons? 2 and 2, 4 pi electrons. But 4 pi electrons is not follow the Hückel rule. N is equal to 1 by 2. So it does not follow the Hückel rule. So it is not aromatic. Let's go into the another example. Here you can see that it is cyclic. It have two pi bonds that are separated by one sigma bond. Okay, remember one thing, the trick, that two pi bonds, one pi bond and one pi bond are separated by one sigma bond. Pi bond and minus, pi bond and plus, pi bond and lone pair separated by sigma bond, one sigma bond. Also they are will be in conjugation. Here conjugation is happen. And how many 4n plus 2 pi electrons? Delocalized pi electrons. 2, 2 and 2, 6 pi electrons. Okay, you can see here n is equal to 1. So it is aromatic and it is also flat. All the carbon have sp2 hybridization. Okay, simple. And another is the carbon which is connected to the ethyl. Okay, but here you can see it is cyclic but having no conjugation. Why? Two pi bonds. Here you can see that two pi bonds are separated by, you can see here that two pi bonds are separated by two sigma bond. You can see here simply there will be no conjugation. It is not aromatic. Simple. And if you count the 4n plus 2 is equal to 4, because there are 4 pi, you will also get n is equal to fractional value, not integer value. So simple it is. Okay, and also it is not a flat molecule. Why? Because the carbon will be in the out of the plane and this system, okay, is in the plane. Okay, so it is not aromatic. Let's go into the another example. Here you can see that tropylium cation and without the positive charge. Okay, you can see here simply that there are 3 pi bonds. Okay, simple. Okay, it is 3 pi bonds here and here also 3 pi bonds, but here the carbon will have positive charge. So what happened? It is cyclic. It have conjugated delocalized pi system. Why? Because all the pi bonds are separated by sigma bond, one sigma bond. Pi bonds positive charge separated by one sigma bond. Pi bonds positive charge separated by one sigma bond. Conjugation is here and there are 4n plus 2 pi electrons. Yes or no? Yes, there are 6 pi electrons and 4n plus 2 rule is followed. And here carbon is sp2 hybridized. See my arrow. Okay, it is sp2 hybridized. So all the carbons are in plane and it is planar system. so it is aromatic. Okay, you can see simple. Okay, but what about this? What about this? That here you can see that it is cyclic molecule. Yes, cyclic. And second rule is conjugation. No way, there is no conjugation. Why? Because here you can see also that two pi bonds, this pi bond and this pi bond are separated by two sigma bonds, so there will be no conjugation. And here you can see delocalization is in the half system, not in the whole system. Okay, the second rule is not followed. Third rule, 4n plus 2 pi electrons here. Okay, you can simply see that there are 6 pi electrons, but you will get also n is equal to 1. Okay, n is equal to 1, but it is not flat molecule, because this carbon, you can see my arrow, that it is sp3 hybridized, and this sp3 hybridized carbon will be in the out of the plane. You can see it in the image also, that is how the 3D structure is given you in the image. Okay, that this carbon is in the out of the plane. Okay, so simply it is not aromatic. We will discuss in later stage that it is anti-aromatic or non-aromatic. Okay, simply we will discuss in later stage. Okay, here you can see that it is cyclopropane having positive charge on this carbon, and here also cyclopropene. Okay, simply both of these compounds are given you. But what about the answer? You can see here that it is cyclic molecule. Okay, here positive charge cyclopropene, and it have conjugation also, because this pi bond, you can see simple, this pi bond, here this pi bond and positive charge separated by one sigma bond, this pi bond and positive charge also, here you can see sigma bond, one sigma bond. So conjugation is here, delocalization will be happen here. Third rule, 4n plus 2 rule. Okay, you can simply see that 4n plus 2 is equal to 2, and you can get the n is equal to 0. So 4n plus 2 obeyed here. Fourth rule, that it is flat molecule. Why? All the carbons are sp2 hybridized, and this positively charged carbon also sp2 hybridized, you know very well about it. So it is aromatic compound, and here there will be no conjugation. Why? Because this carbon is sp3 hybridized. Okay, there will be no conjugation, and it is not flat molecule. Yes, you have n is equal to 0 because there are 2 pi electrons, but two rules are not followed and not aromatic compound. Okay, so I have solved it. Okay, in the previous section, that 4n plus 2 is equal to 6. Okay, n is equal to 1. It is cyclic, planar, both are cyclic, planar, conjugated pi system, and 4n plus 2 pi electrons and flat molecule. I have discussed in the above section. Okay, it is both are aromatic. Remember this thing. Okay, what is anti-aromaticity? Anti-aromaticity is a property of the anti-aromatic compound. But remember one thing, aromaticity and anti-aromaticity both are same, but the property are different. They both are cyclic, planar and pi electron system in the conjugated delocalized pi electrons. Okay, remember this thing, delocalized pi electrons. But how many pi electrons? 4n delocalized pi electron. So if the molecule have 4n delocalized pi electron, not 4n plus 2, it will be anti-aromatic compound. So remember this thing, the anti-aromatic compound have high energy and highly unstable. You know, highly unstable have highly reactive. Okay, highly unstable means highly reactive. Okay, and low stability. And to avoid the instability, this molecule may change its shape. We will discuss in the example section, and in the later video I will make the video on it about how they change the shape of it. Okay, why? They are unstable. They are unstable and highly reactive. So this is all about the anti-aromaticity. What the rules? Because we require rules. First is same as the aromaticity, molecule cyclic. Okay, second also same, third also same, they must be flat, and fourth rule, that they have 4n pi electrons. Okay, remember the one thing. So it will be anti-aromatic, and n is equal to 1, 2 and 3. Remember, not 0. Okay, because if you count n is equal to 0, you will get 0 pi electrons. Okay, but systems have some pi electrons. Okay, so n is equal to 1, 2, 3. Non-aromaticity. Remember one thing, that if the molecule does not follow any of the rule, that planar, cycle and delocalized conjugated pi system, if the molecule cannot follow any one of the rule or all the three rule, it will be non-aromatic compound. Okay, any one of the rule, whether it have 4n plus 2 pi electrons or 4n pi electrons, we should not consider it. We should only consider that if the molecule cannot follow these three rules, it will be non-aromatic compound. Okay, remember this thing. So I hope you understand anti-aromaticity, aromaticity, non-aromaticity. Okay, simply remember the things and rules. Okay, and remember one thing, the pi electron counting. Okay, pi electron counting is very important. If negative charge here, simply see that if whether the compound have negative charge, okay, it have negative charge, but see that if this negative charge is parallel to the p orbital or not. Okay, and also positive charge. Okay, positive charge will always be in the parallel to the p orbital. Second and third, if the molecule have or any of the atom have one lone pair, it will not be in conjugation. Usually it is happen. Okay, and fourth rule, if a molecule or atom like oxygen, nitrogen have two lone pair, you should count one lone pair as a conjugation. Okay, so simply remember the pi electron counting so you can understand and solve the example on your own. I hope you understand very well. Okay, so let's go into the another examples sections. Pentylene, here you can see. Okay, pentylene, but here you can see that what happened, cyclic molecule. Okay, it is cyclic, but here you can see conjugation. Yes or no? All the pi bonds are separated by one sigma bond, so here conjugation is exist. Third rule, 4n plus 2 pi electrons. Yes or no? 2 and 2, 2 4s are 8. Okay, so it is a 4n pi electrons, so it is simply anti-aromatic. Okay, you know, it is flat, you know, it follows three rules, but it have 4n pi electrons, so it is anti-aromatic. Another is biphenylene. Okay, you can see it is cyclic system. It have conjugated pi electrons. Yes or no? Yes. All the pi electrons are separated by one sigma bond. Simply see all the pi bonds that are separated by one sigma bond. Okay, you think that this pi bond is separated by one sigma bond or not? Simply see here, this pi bond and this pi bond are also separated by one sigma bond. This pi bond separated by one sigma bond. All the carbon are separated by one sigma bond. There is conjugation. Third rule, how many pi electrons? 2, 2, 2, 6 and 6 and 6, 6 plus 6, 12. So 4 3s are 12. So here 12 pi electrons. So 4n pi electrons. Okay, so it is anti-aromatic. Okay, I hope you understand very well. Here you can see another example. I am not showing the name of it. Okay, it is cyclic. It have not conjugation because all the pi bonds are not separated by one sigma bond. You can see two pi bonds, one pi bonds and one pi bonds here are separated by two sigma bonds, so no conjugation. Third rule, 4n plus 2 pi electrons. Yes or no? 2 and 2, 6 pi electrons. Yes, it have 4n plus 2 pi electrons, but it is not anything about which rule is not followed. It is not in conjugation. So remember one thing, that in non-aromaticity I have mentioned that if the molecule doesn't follow any one of the rule, whether it have 4n or 4n plus 2 pi electrons, but it will be not aromatic. Okay, non-aromatic. Okay, another is, you can see sulfur has two lone pair, thiophene. Okay, you can see simply here it have 4 pi electrons. Yes or no? But you are wrong. Okay, here you can see there are two lone pairs, but you should count one lone pair as a conjugation. Okay, you think about it. I have mentioned in the pi electron count thing, so there are 6 pi electrons and 4n plus 2 rule is followed. It is cyclic. It have conjugated system. Why? Because all pi bonds and pi bond and lone pair have separated by one sigma bond. Yes, all the 4 rules are followed by this molecule. It is aromatic compound. It is flat also. You can see cyclobutadiene here. All the pi bonds. Yes, it is cyclic molecule. It have conjugation. Why? All the pi bonds are separated by one sigma bond. Pi, sigma, pi, sigma, pi. Third rule, it have 4n plus 2 pi electrons or not? 2 and 2, 4 pi electrons. Okay, so it have 4n pi electrons. 4, 1. Okay, so 4 pi electrons. So it is anti-aromatic. It is flat. Okay, you know very well about it. But it doesn't follow the 4n plus 2 pi electrons, 4n pi electrons. Okay. Last example, but you can see here that azate. Okay, this molecule is very, remember this thing. Okay, here you can see that it is a cyclic molecule. Yes, it is cyclic molecule. And here you can see conjugation. Why? Because all the pi bonds are separated by one sigma bond. Yes, it is right. But remember one thing, this lone pair cannot take part in conjugation. Why? Because the nitrogen have 3 valency and 3 valency are satisfied. And it have already make the pi bond with this carbon, okay? So it cannot make the another pi bond, okay? One pi bond is already exist and one p orbital already exist in the out of the plane and perpendicular to the this square plane, okay? So this lone pair cannot participate in conjugation, okay? Because one pi bond exists here. So you should remember that one lone pair we should not count it as a conjugation. So here only 2 pi bonds are in conjugation. Third rule, how many 4n plus 2 pi electrons or 4n electron? 4n pi electrons. How many 4 pi electrons here? Okay. So it is simply anti-aromatic. You understand very well. But simply see this, that as it is a anti-aromatic compound. Okay. It is have 4n pi electrons. Hope you understand very well about it. Okay. So let's recap about we have discussed these examples in the above section, in which I have said you that I am showing you not aromatic, but we will discuss about that it is anti-aromatic or non-aromatic. Let's go into it. Okay, it is aromatic simply. Okay, we have discussed about it, but whether it is anti-aromatic or non-aromatic, you can see here that it is cyclic. It have delocalized pi system. Why? Pi bond and positive charge separated by 1 sigma bond, pi bond and pi bond separated by 1 sigma bond. And how many pi electrons? 4 pi electrons. 2 and 2, 4. Positive charge have no any electron. It is simply anti-aromatic. Simply count is anti-aromatic. Here you can see also it is aromatic. Okay, we have discussed about it, but we should discuss about this, that it is anti-aromatic or non-aromatic. You can see that 2 pi bonds are separated by 1 sigma bond, right? But here you can see that 2 pi bonds are separated by 2 sigma bond, like this. See my arrow. Okay, this and this. So it have not conjugation, not in the whole system. Okay, so it is simply doesn't follow the one rule, so it is non-aromatic. The example is this. Okay, you can see this is aromatic, but why this is not aromatic? Because conjugation is not followed in the whole system. Why? Because this carbon have no positive lone pair and negative charge. So it is simply non-aromatic. Okay, we have discussed in the above section. Another is this cyclopropene here. It is aromatic, but it is non-aromatic. Okay, why? Because it doesn't follow the one rule. What rule? Simply pause the video and remember the rules. That I hope you pause the video and solve it. Okay, I am showing you the answer. That this carbon have sp3 hybridized carbon and it doesn't follow the second rule, that conjugation. Here there is no conjugation. Why? The pi bond here, one pi bond is separated by 2 pi bonds, 2 sigma bonds. Okay, and here also it is not flat molecule. It is simply non-aromatic. Okay, here, okay, I have discussed in first rule. Okay, you can see that it is benzene. Okay, you can see simply it is benzene. Benzene is aromatic. Okay, 1,3,5-hexatriene. It is not cyclic molecule. And you remember the thing that in non-aromaticity, if it doesn't follow any one of the rule, it will be non-aromatic. Okay, in the last example, Pyrol, you can see simply that Pyrol is a aromatic compound. But why it is non-aromatic compound? Because it is cyclic and doesn't follow any one rule. Okay, so it is non-aromatic. So I hope you understand all the concepts. Okay, so if you like my video, please like and share and subscribe to my channel, and also share with your friends which prepare for the NEET, Csir-net and other GATE competitive exam. So thank you so much for watching my video. I will meet you in the next video with some examples. But remember one thing, I will be always teach you without gramming. So thank you so much for watching my video.